This is part 2 of assignment 2.2 by James Boxford. In this video I'll be describing the respiratory responses, the neuromuscular responses, and the energy system responses. Respiratory responses. Tidal volume. I believe that the tidal volume would increase during steady state exercise. Tidal volume would increase during steady state exercise because more oxygen is going to be required by the working muscles. This means that you'd breathe more. Tidal volume would then plateau during the middle stages of exercise because there'd be enough oxygen to supply the working muscles. Also, gaseous exchange would be the same. So the amount of air coming in would be the same as the air going out. So there'd be less need for it. Breathing rate. I believe that the breathing rate of a performer would increase during steady state exercise. The breathing rate would increase because of the requirement for oxygen by the working muscles. They need oxygen to help them move. Also, there'd be a demand on oxygen because the body would need it due to the fact it has partaken in exercise. When exercise occurs, the muscles begin to contract, and oxygenated blood helps muscular contraction occur. And when there is not enough oxygen, the breathing rate increases. During steady state exercise, it is done at a maximum of 75% of the intensity of anaerobic exercise. So there should be enough oxygen. Because of this, it would increase steadily and then possibly plateau and then drop off slowly towards the end of the exercise. The effects of pH and temperature on the oxygen desiccation curve. I think that steady state exercise would have a large effect upon the oxygen desiccation curve by pH and temperature. The pH of something would impact oxygen desiccation curve because it would move the curve to the left. This means that there would be a higher saturation of oxyhemoglobin in the blood. A change in temperature sees the curve move to the right. This means that there's less oxyhemoglobin in the blood. As you can see in the diagram here, it explains this all here. I'll freeze this for a moment to allow you to look. Now I will be describing the neuromuscular responses to steady state exercise. When pliability of muscles. During steady state exercise, I believe that there will be an increase in the pliability of muscles. This is because blood is being pumped into the working muscles, which means they become more pliable. Pliability is known as how flexible a muscle movement is. So there'd be an increased amount of pliability because the blood would be warming the muscle up, and when the muscle is fully warmed, it would be at its full range of motion, which means that the performer will be able to compete at their highest intensity. Increased transmission rates of nerve impulses. During steady state exercise, I believe that there would be an increase in the amount of nerve impulses that are sent to the body and working muscles. This is because the muscles need to be told to work and the rest of the body has to do what it normally does. The increase occurs because the body is not used to having the contractions and signals that it needs to. Muscle spindles. Muscle spindles are proprioceptors that are found within skeletal muscles. They detect muscle stretch and initiate a reflex that resists the stretch that is occurring. Every time that a muscle becomes stretched, the muscle spindle responds to this stretching and sends information to the spinal cord where it is processed. The secondary sensors detect the information about the degree of the stretch and send this to the central nervous system. The CNS, or central nervous system, then sends the information to the motor neuron, where it forces the muscle to contract, where it reduces the stretch. And on the right of my slide here, there is a diagram of how a muscle spindle works. Muscle spindles are crucial in steady state exercise because they are telling the muscles to work. This is predominantly found within steady state exercise within the legs because the hamstring groups and the quadricep groups are made up of many intricate muscles, and there has to be one that tells all of these to go, and they all have to contract at the same time. I'll leave the diagram up for you to get a look at. Also, you can see the Golgi tendon organ at the bottom of the muscle spindle. This will now be explained on the next slide. A Golgi tendon organ. A Golgi tendon organ is a proprioceptive sensory receptor organ that senses the change in muscle tension. During steady state exercise, there would be an increase in muscle tension. This is because the body would need to be pump more blood back to the heart using the skeletal muscle pump. The skeletal muscle pump works as in the muscles contract, which forces blood up and out of the veins in the muscle, and then the veins have valves which prevent backflow, and these valves then are clamped shut, which stops blood going back into the muscle. This is designed so that all blood that is below the heart can be pumped straight back up into the heart and get it sent oxygenated and circulated back around the body when it is most needed. I will now be discussing the energy system responses to steady state exercise. Adenosine triphosphate production. I believe that the production of ATP or adenosine triphosphate will increase during steady state exercise. I believe this because it is used as an explosive power and lasts for 1 to 3 seconds. So as the exercise begins, the performer would need to use the ATP energy system. This is because they need to get over that first little bit of exercise before their body can start working aerobically. Because the first bit of exercise that you do, that'll be for your body, that'll be the immediate contraction of all the muscles that it needs to use, and it will just need to be using the ATP system. The aerobic energy system. I believe that the use of the aerobic energy system would increase. This is because of the maximum heart rate that would be used. When you're working aerobically, you should only ever work at 75% of your max heart rate. And for a 16-year-old client, which we used in our 3 tests, we discovered that their max heart rate should have been 157. So this is according to their resting heart rate. And their heart rate should no longer exceeded this. The aerobic energy system would be used also because it lasts longer than 3 minutes, and there is no byproduct of this that can be harmful for the body. And the steady state exercise has to last for at least 20 minutes or longer. It uses glycogen stores along with other fatty stores which have come from food intake into the body. And these are already found within the body, so no extra effort has to be required from the performer or the performer's body for this energy system to be sourced. And because of this is why it is so reliable and used more often during aerobic exercise. Anaerobic glycolysis. I think that the anaerobic glycolysis system would be used and the production would increase. This is because it again would be used towards the beginning of the event. The anaerobic glycolysis system works the most efficiently up to 1 minute. However, after this it slowly drops off and is not as effective to this point. It can work up to 3 minutes, but it is mostly used up to 1 minute before the aerobic system kicks in. It is normally used in short distance events. However, it can be used in steady state exercise at the start. This is again because of the fast contraction of the muscles at the start of the exercise that would almost be shocking the body into using it. The mitochondria. The mitochondria are also known as the powerhouse of the cell and contain all protein and energy within a cell, and many of the mitochondria can build up a muscle. And when all the energy is being found within the mitochondria in the muscle, they produce all of the energy and provide all the muscle with the protein that it needs to use. The mitochondria would respire during steady state exercise and then begin to plateau in the amount of the respiratory rate of the mitochondria. This is because there would be the rest of the body would be working at a plateau as well, so there'd be no need for the extra respiration. Now I'll move on to the Krebs cycle. The Krebs cycle would increase during steady state exercise. This is because carbon dioxide is produced along with hydrogen, which is crucial for the electron transport chain, which features next. The Krebs cycle also produces oxalic acid, ATP, and citric acid. Citric acid is produced so that the cycle can continue, and oxalic acid is also produced so that the cycle can continue. In the diagram on the right, it also shows the electron transport chain. I'll be describing this in detail next. Hydrogen is crucial for the electron transport chain. The electron transport chain. The electron transport chain is important because it delivers hydrogen where it is needed and produces energy, which is crucial for the body to continue working at a steady state during exercise. If the energy wasn't produced, then the body would not be able to perform at its highest level. The electron transport chain produces 34 moles of ATP, and this is then used to create energy, which allows the body to keep going through the steady state. This is the end of this video. In the next video, I'll be talking about the analysis of a performance at steady state. I'll be analysing 3 performers and comparing their results to normative data. Thank you.